I've been trying to look for this from textbook and no textbook tells me about it. Okay, so I'm telling you, textbook assume that this is understood. Everyone should know about it. Not true at all. Not everyone will know about it. I did not know about it until 4 years ago. What is in plane and out plane? Okay, you can go to the textbook. You can start reading it. Okay, so this is the thing that I want you all to remember. Okay, what do we mean by in plane and out plane? Okay, so hopefully for now, we are okay with Mohr circle. Okay, so you guys can do the basic stuff on Mohr circle. In fact, this is not basic in terms of Mohr circle. Uh, within 2D, this is the most complex you will get. Okay, you will not get any more difficult than this. Then probably in 2 weeks time we'll go into 3D Mohr circle. But I need 2D now for design of transmission shaft. Okay, so I'm going to stop here on Mohr circle. Then the next thing that we're going to do, okay, the next thing we're going to do, this is the most critical part, and it's said that attendance is not high, but this is a part where a lot of students are having great difficulty with this topic. Okay, so I'm going to go really slow. So we're going to talk about design of transmission shaft. Okay, so design of transmission shaft is solely a mechanical engineer's problem. You don't get civil engineering doing this stuff at all. Okay, they are not designing anything that rotates. Okay, only we are. So I'm going to take this diagram. So again, you have this diagram on Avenue to Learn. Okay, we'll look at this diagram. So this diagram is a shaft, right? It's a transmission shaft. What you see down here, this is the motor gear. So the motor is the driver. Okay, the motor gear is so it drives the shaft, right? So over here we have a shaft. Okay, so the shaft, on the shaft we attach 2 gears. Okay, so those 2 gears are driven. Okay, so I want you to look at what is a driver and what is a driven. Okay, right? So and both gear A and B are attached to a shaft. Okay, the confusing part is we have to find out, okay, the critical is critical to know the direction of the force. Okay, direction of the force or forces. If the force direction you got it wrong, okay, the design of the shaft is done. So this problem, okay, designing of shaft is all based on one analysis. Okay, as I said, if you got this analysis wrong, okay, you're done. When I taught this last term, a lot of students got the transmission of the forces wrong. Okay, so this is one of the term tests. The average was 42. It was really bad. Okay, because the direction got it wrong. Okay, I know about it. Okay, why? Because this is one part that you are going to see more in the next course you're going to take, which is 305. Okay, and this is the basics. You have to know this. Okay, now as I said, I will drive the important point. What is critical? So now, based on the transformation over here, okay, we're going to look at the shaft in this direction now, in this orientation now. Okay, so I'm going to change. So this will be my Y. This is my X. Sorry, Z. And this will be my rotation in the X direction. Okay, so we are basically going to view this from this point of view. Okay, right. And I want you all to take note that the driver, this is important. The driver, this is the rotation direction. Okay, so this is the rotation direction. Now, the rotation direction you specify. You want it to go anti-clockwise, it goes anti-clockwise. You want it to go clockwise, it goes clockwise. You make the decision. Okay, you make the decision. Right, so I'm going to sketch all the gears now. Okay, so the less important gear, I'll use a lighter color. So we have, I'm going to draw our center line. Okay, then we have one set of gear. Okay, so we have one gear. Maybe I'll draw it bigger a bit. Right, so this gear at the top, this is our, so this gear on top, this is our motor gear. Okay, this is our motor gear. And we specify the rotation is in this direction. Right, so this is the rotation direction. Okay, then at the bottom, so the motor gear is the driver, right? So if the driver is rotating that direction, okay, over here, right? So this is the force generated by the driver, okay, by the driver, right? Then we have a shaft. Okay, then we have a shaft down here. So I'm going to draw my shaft down here. Okay, so we have a shaft down here. So this shaft, right? So we're going to draw a shaft. So this is our shaft, right? So this is our shaft. And then it's connected to two gears. Okay, so one, oh, sorry, I think I have to move this down lower because it's proportionally wrong, right? And then this shaft is attached to one set of gears. Okay, so the set of gears, so 1, 2, 3, 4, 4.5, 4.5, 1, 2, 3, 4. Right, so one set of gears. Hey, what am I doing? Okay, so one set of gears. So what I've just drawn down here, right? What I've just drawn down here, this is our gear A. And gear A is self-driven. Okay, it's self-driven. Right. What is the question now? What is the reaction force at gear A? Is it going to follow the driver gear or is it going to be opposite? Anyone, please. I repeat again. What is the direction? What is the force direction of gear A that is what? Driven. Same direction of the driver or opposite? Anyone? No? Okay. I will let's say if we assume, okay? If we assume that is the same direction. Okay, so I'm going to use red in color. We're going to assume that gear A, the driven, is in the same direction. Hold on. The color identification is very bad. So we're going to assume it the same direction. So this is the force of the driven gear A. Okay. So if you assume that, we are going to have a problem. So logically, what's wrong? Anyone? If you assume this is wrong. Why is it wrong? Okay. It's wrong because you mean to tell me the driver, right, and the driven, if they are the same direction, what does it mean? Gear A will help the motor gear. Does that make sense? If you assume this, what you're assuming is gear A will assist the motor gear. Does that make sense? Anyone, talk to me. Does that make sense? That the driver and the driven, the forces are the same. It does not make sense. The driven, the gear A, will oppose the driver. That's why we need the what? That's why we need the motor, right? If it follows the same direction, we're going to have issue. Means, okay, if I put 10 kilo, if I put 10 kilowatt here, or okay, let's not talk about kilo. If I put 20 Newton here, and gear A somehow is going to give me 10 kilonewton, the output of the entire system is 30 kilonewton. That is wrong, right? So this is wrong. This is wrong, right? So gear A, the valid one, is the driven gear is always a resistance. I'll write this down. The driven gear is always a resistance, right? So when that's the case, the right answer is this is the right direction for force. Okay, so this is the force of the driven gear. Right? It will oppose. Okay, so this is wrong. I'm gonna make sure you know that this is wrong. Okay, that is wrong. Right? So this is the force of the driven gear A. So this is valid, right? Because it will resist the motor gear or the driver gear force direction. Okay. Now we have a gear B behind, so gear B is larger. So we have another gear B behind. So I'm going to draw gear B. Okay, so gear B is behind. So gear B is 2, 4, 6, 2. So this is gear B now. Okay. So what I've just drawn over here, this is your gear B. So this is again your driven gear. Now, question for you guys, which direction? Is it going to be the same direction as